In this lesson, we're going to evaluate composite functions where we're given a table of values or a set of ordered pairs. So the first example is a table of values. So notice it looks like a table. You have the x coordinate, you have the function value for f of x, and then you have g of x. Let's just make sure you understand how to read this. So basically what that's saying is that when x is -4, f of -4 is 3. That's what that's saying. So make sure you understand how to read this table. So just as a few examples, notice this says this. When x is -4, f of x, remember x is -4, so that means f of -4 is 3. And then that means g of -4 is 2. That's what that means. That's how you read this table. Same thing if you said this, f of, let's say, -1. So f of -1 is 1. And then g of -1 is -6. So g of -1 equals -6. So that's how you read the table. So remember, this right here means when x is -4, the y value is 3. When x is -4, the y value is 2 for the function g. When x is -1, my y value, or my function value, is 1. When x is -1, my y value, or my function value, g of x is, or g of -1, is -6. All right, so that's how you read that. So this is your x, this is the y. Okay? Now, remember, we say y here, but remember your function name is f of x, and this one is g of x. Okay? So that's how you read this. It's important you understand how to read a table that looks like this. All right, so that's how you read it. That's how you go from here to here. All right. So now, the other thing you have to remember is this. So the other thing you have to know is that this open circle right here means composition. All right. So composition. So remember the definition of composition. So the definition of the composition of two functions is this. So if you have g composed with f at x, let's say, then I can rewrite by definition, that means the same thing as saying g of f of x. So that's important to know how to rewrite this notation into this notation. Same thing if you said f composed with g at x. So f composed with g of x at x means f of g of x. So notice the order. So g is listed first, f is listed second. In this notation, g is listed first, f is listed second. So this function f of x is inside the function g. And the function g of x here is inside, see f is listed first, is inside the function f. All right? Okay, so let's look at some examples. All right, so the first example is this. So you want to find f composed with g at -2. Now remember, this does not mean multiplication, so don't say f composed with g times -2. That's not multiplication. All right, so f composed with g at -2. So the first thing you want to do is write the definition. So by definition, this means f of g of -2. That's what that means. All right, so using this definition that we just discussed. Okay. All right, so then the first thing you're going to do is you're going to find that inside value. So g of -2. So remember g of -2. So go off to the side and kind of figure out what g of -2. So remember, g of -2 equals something, right? So the question is, when x is -2, what's my y value when x is -2? But you got to be looking at the function g. So when x is -2, here's where x is -2, right here. When x is -2, what is g of -2? Well, g of -2 is 4. So g of -2 is 4. So this was for number 1A. All right, so g of -2 is 4. So now in place of g of -2, I'm going to substitute 4. So this becomes f of 4. And then go to the table and remember what that means. So 1b, oops, sorry. So now f of 4 means what's the y value? What's the y value when x is 4? So when x is 4, so locate x equal 4. So that's right here. F of 4 is -6. So the answer is negative 6. So what that means is this. F composed with G at negative 2 equals 6. So that's the answer. Okay? All right, so that's how you do that. So it's not a very difficult idea. Okay, so that should be negative 6. Sorry, negative 6. All right, letter B. Same thing. You're going to do the same thing. So you're going to say, well, that's going to equal G of F of negative 4. Okay, so G of F of negative 4. Now we got to figure out what F of negative 4 is. So find that inside function first, that inside value first. So remember F of negative 4, so let's think about 1b. So F of negative 4 means what is the y value when x is negative 4? But I have to use my function f. Your function f is that second column. So f of negative 4, so here's where x is negative 4. F of negative 4 is 3. So now we know that f of negative 4 is 3, right? So now what that means is that this right here is 3. So replace f of negative 4 with 3. So this becomes g of 3, right? And so we've got to figure out what g of 3 is now. So g of 3 means when x is 3, what's my y value? But I have to use my function g. So when x is 3, locate where x is 3. So that's right here, right? So when x is 3, I have to, remember, you got to make sure you're using the correct one. So always go back and look to see your function. So I'm looking for g of 3. So g of x is my last column, that third column. So g of 3 is going to be 8. So the answer, g composed with f at negative 4 is equal to 8. So that's the answer. Okay? So very simple. It's not a difficult process, is it? All right, so by definition, let's do this one. So this says g composed with itself at negative 3. So by definition, this means g of negative 3. So then I have to figure out what g of negative 3 is. That's a negative 3. So I got to figure out what g of negative 3 is. So let's go off to the side and kind of figure that out. So that's 1c. So g of negative 3, remember what that means. So g of negative 3 means when x is negative 3, what's my y value? But remember, you have to use the correct function. The correct function is g. So when x is negative 3, so let's find negative 3. That's right here. When x is negative 3, g of negative 3 is 0. So g of negative 3 is 0. So now what I found is that this value right here, this function value, is 0. So this becomes g of 0. And then we just got to figure out what g of 0 is. So again, remember what that means. When x is 0, what is my y value? So when x is 0, when x is 0, that's right here, g of 0 is negative 5. And so the answer, you're going to say g composed with g at negative 3 equals negative 5. All right, and then we do d. So d says f composed with itself at negative 1. Well, by definition, this means f of negative 1. So now let's figure out what that inside function value is. So f of negative 1. So for 1d, we have to find f of negative 1. So remember what that means. What is the y value when x is negative 1? But I have to use my function f. So when x is negative 1, I go to my table, I find negative 1 for x. So x is negative 1 here, that's this row. F of negative 1 is 1. So I've just found that f of negative 1 is 1. So what that means now is this. This part here is 1. F of negative 1, remember we just found to be 1. So this becomes f of 1, and then I just got to figure out what f of 1 is. So remember what that means. What is the y value when x is 1? So when x is 1, right here, f of 1 is negative 3. So what that means is that my answer, f composed with f at negative 1, is equal to negative 3. Letter E, f composed with g at negative 4. By definition, this means f of g of negative 4. So remember, make sure you understand that definition. Make sure you know how to write this into this. So what's listed first goes first, what's listed second goes second. So this part here is going to be inside your function f. So g of negative 4 is what I find first. So in 1e, if you think about it, g of negative 4, that's what this is. So g of negative 4 means what is my y value when x is negative 4? But I have to use the function g. So when x is negative 4, that's this one here. G of negative 4 is 2. G of negative 4 is 2. So I found g of negative 4 to be 2. So what that means is this. That means that my function value here is 2. So then I rewrite this as f of 2. And so now I got to find f of 2. Well, f of 2 means what is my y value? What is my y value when x is 2 for my function f? So when x is 2, I keep pulling this over, and I mean to pull this over. When x is 2, that's this right here, f of 2 is 4. F of 2 is 4. So what that means is that this right here equals 4. So f composed with g at negative 4 is 4. So remember, all these are equivalent. All of these, this is equal to this, is equal to this, is equal to this. So therefore, this equals this. This notation is equal to this notation, which equals this, which equals 8. So therefore, this must equal 8, and so on. Okay? All right, and then finally, f for this example, letter f. So g composed with f at 1, so that means g of f of 1, right? So that's what that means using our definition. So it's very important that you rewrite this like this. And so we always find the innermost parentheses first, that inside function value. So I got to find f of 1. So for 1f, I need to find f of 1. So that means when x is 1, what is my y value? I'm using the function f. So when x is 1, right here, f of 1 is negative 3. So f of 1 is negative 3. So what that means is that this right here, f of 1 is negative 3. So remember, you got to find the inside function first, which I just did. It's negative 3. So now I'm going to find g of negative 3. And so now g of negative 3 is going to equal, when x is negative 3, what is my y value from a function g? So when x is negative 3, I locate negative 3, which is here. G, so here's my function g. G of negative 3 is 0. So g of negative 3 is 0. So remember, all these are equivalent. So therefore, you're going to say g composed with f at 1 is equal to 0. All right. So that was example 1. All right. So it's not that difficult. It's a fairly simple process. But remember, you do have to know your definition for composition. You do need to know how to rewrite, how to go from here to here and backwards as well. Okay. And you also need to know how to read this table. And this is what this was about. So remember, from the table, we were able to understand that f of negative 4 means 3, g of negative 4 means 2, and so on. Okay? All right, and so knowing all of this helps you to get all of this. All right, so that's number 1. Let's look at another table. All right, number 2. All right, so here's number 2. So you're given this table of values. So just like the previous one, make sure you know how to read this table. So just to make sure you understand this, we'll look at a few examples of how to read this. So your table, okay, so your table, from your table, you know, for example, that, remember, this is your x, this is your y value for your function f, and this is your y value for your function g. So these are your y values for function f. These are the y values for your function g whenever x are these numbers. So when x is negative 3, what that column means is this. F of negative 3 equals this 4 that you see here. So when x is negative 3, my y value is 4. If you look at this column right here, using x negative 3, that means g of negative 3 is a positive 3. So when x is negative 3, my y value is 3 for my function g. And you can just keep going down, right? So now when x is negative 1, this means f of negative 1 equals negative 3. And then so on. So g of negative 1 equals 2. G of negative 1 equals 2. Okay? All right, so that's how you read this. Now, let's look at number 2. So number 2, we want to find f composed with g at negative 1. Now, remember, composition does not mean multiplication. So remember, composition means you take one function, put it inside of another. Take this function, put it inside this one. Take this function, put it inside this one. That's what composition means. So by definition, though, we know this. We know that f composed with g at negative 1 by definition means f of g of negative 1. And so now I have to find the innermost function first. So we're going to find g of negative 1. So if you need to write things down, write it down if you have to. So for 2a, you want to find g of negative 1. Well, remember what that means. That means when x is negative 1, what's my y value? So, but remember, we're using function g. So here's where x is negative 1. G of negative 1 is 2. So g of negative 1 is 2. So that's this, though. Remember, that's only this part here. So g of negative 1 is 2. So I'm going to replace this function value, or this function value is 2. So g of negative 1 is 2. So I'm going to replace g of negative 1 with the value 2. So this becomes f of 2. Now we go and do the same thing. So in our table, this means when x is 2, what's my y value for my function f? So when x is 2, my y value for f is negative 4. So this becomes negative 4. So remember, all these are equal, right? All these are equal. So what that means is this. So that means in your answer, you're going to say f composed with g at negative 1 equals negative 4. All right? Very simple, just like the previous example. All right, in B, you want to find g composed with f at negative 3. So let's do the same thing. Let's use our definition. By definition, this means g of f of negative 3. So g is listed first, g is listed first. F is listed second, f is listed second. Now remember, by definition, this composition means I take f of negative 3 and I put it inside the function g, and that's what you see here. F of negative 3 is inside of g. All right, so now I've got to find this innermost function value first. So let's find f of negative 3. So if you need to write it down, do that. So f of negative 3 is what you're trying to find. So when x is negative 3, what is my y value from my function f? So I go to my table. Here's where x is negative 3. I want to find f of negative 3, so that's that second column. F of negative 3 is 4. So this right here, you found to be 4. So what that means I do now is this. I found my function value for f of negative 3. Now I've got to find g of 4. So that's easy now. So I go to my function, I go to my table. When x is 4, which is here, that last row, when x is 4, g of 4 is 5. So all of these are equal, right? So that means your answer, you're going to say g composed with f at negative 3 equals 5. And that's the answer. All right, in C, same thing. F composed with itself at negative 1. All right, so by definition, this means, I'm going to write it down here, this means f of negative 1. So now I've got to find this innermost function value first. So I've got to find f of negative 1. So if you have to write it like this, go ahead and do that. F of negative 1 equals, so I go to my function, I go to my table. When x is negative 1, I need to use my f of x column to find my y value. So when x is negative 1, which is here, f of negative 1 is negative 3. So this, let me write it right here. So that's negative 3. So now so what that means now is that in this part here, I found this to be negative 3. So now this right here. So now this becomes f of negative 3. Sometimes students find it a little bit easier to write it vertically like this rather than horizontally, but it's up to you. Just make sure you show enough steps to where I can understand where you're getting all your work from. So now I need to find f of negative 3. So f of negative 3 means when x is negative 3, what is my y value for my function f? So here's where x is negative 3. F of negative 3 is 4. So that equals 4. So what that means is that your answer, you're going to say f composed with f at negative 1. F composed, f composed, let me write it. F composed with f at negative 1 equals 4. And there's your answer. D, g composed with itself at 3, by definition means g of 3. So let's find g of 3 first, the innermost function. So g of 3, so this is 2d. G of 3, if you have to write it like this, go ahead and do that. So g of 3 means what is my y value when x is 3? So when x is 3, here's where x is 3, right? And I want to find g of 3, so I'm going to use my last column. So g of 3 is negative 1. So g of 3 is negative 1. So I'm going to replace this right here because I know it now. G of 3 is negative 1. So g of negative 1, and then I figure out what g of negative 1 is. So remember, this means what's my y value when x is negative 1? I have to use my function g. So when x is negative 1, which is here, g of negative 1 is 2. So remember, all these are equal. So that means g composed with g at 3. G composed with g at 3 equals 2. And there's your answer, 2. All right, and then let's look at E. So E means f of g of negative 3. So by definition, that's f of g of negative 3. So now I've got to find g of negative 3. So for 1e, that's actually 2e. 2e, g of negative 3 means what is my y value when x is negative 3 for my function g? So when x is negative 3, g of negative 3 is 3. So this is 3 right here. So then this becomes f of 3. So remember, g of negative 3 we found to be 3. So now I need to figure out what f of 3 is. So I go to my function f, and when x is 3, which is here, f of 3 is 5. So that means that this right here, which was your original problem, is equal to 5. So your answer, f composed with g at negative 3 equals 5. And then finally for number 2, same thing. All these are the same approach. You need to find f composed with g at 2. So by definition, this means f of g of 2, just like this, no parentheses. And g of 2 is what I need to find first. So for 2f, g of 2, remember, means when x is 2, what's my y value for my function g? So when x is 2, which is here, g of 2 is 4. So that becomes f of 4. So remember, g of 2 is what I just found. So g of 2 is 4. Okay, g of 2 is 4. Now, I need to find f of 4. So I go to my table, and when x is 4, what's my y value? But using a function f, so when x is 4, my y value is negative 7. So what that means is that the f composed with g at 2 is equal to negative 7. So your answer, you're going to say f composed with g at 2 equals negative 7. All right. So so those two examples provided you should be enough for you to understand how to find composite function values when you're given a table. All right, so the second part of the objective was where it was said, or a set of ordered pairs. Now, before we look at that, I want you to understand that this table that you see here is really a set of ordered pairs. Here's the x, here's the y. for my function f. And then for g of x, here's the x coordinate, here's my y coordinate. So technically, this right here is a set of ordered pairs. It's just written in table form. So what that means is this: if I go back to number 2, just to show you, and if I wanted to rewrite this table of values into set notation, it would look like this. So watch how simple this is. So my function f is going to equal. Now, whenever you write in set notation, you just use the letter f and not f of x. So you say f equals this set. Okay, so don't say f of x equals, just say f equals this set. And so here's my ordered pairs. When x is, now remember this is f here, right? So I'm using all of this. So when x is -3, my y value is 4. When x is -1, my y value is -3. When x is 2, my y value is -4. When x is 3, my y value is 5. And when x is 4, my y value is -7. So that's the set of ordered pairs. So it's kind of like if you covered up g of x, this right here is this: xy, 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 xy. See that? And you could do the same thing with g. So you would say g equals this set of ordered pairs. Now, it sometimes helps if you cover up the f of x function. So there's your x, there's your y, 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 there's your x, and there's your y. So as an ordered pair, as a set of ordered pairs, you would say from a function g equals this set, you'd say -3, 3, -1, 2, 2, 4, 3, -1, and then 4, 5. Okay? And that's how you would write it. So notice this table of values is really a set of ordered pairs in set notation. This would be set notation. So let's go ahead and do a couple examples using set notation where we're finding compositions. It's the same idea except using a table like we were doing. You're using a set of ordered pairs. Or a set notation, I should say, using set notation, because this is, you can think of this as a set of ordered pairs. All right, so let's look at number 3. So it's going to be number 3. Number 3. All right, so number 3, it says determine the composite function values using the set of ordered pairs. So I have a set of ordered pairs. Now I want you to notice that when we did this table, just to show you, when we did this table, notice that the number of ordered pairs was identical for f and f. So when using a table, that's what you're going to see. So for each x, you're going to have an f of x and a g of x. So you're going to have a y value for each of those functions. So the number was the same, right? So 1, 2, 3, 4, 5, 5 points. 1, 2, 3, 4, 5. The advantage to using set notation like this is that the number of ordered pairs doesn't have to always be the same in each case. So notice there are 4 points here and 5 points here, and that's fine, right? That's okay. So that's one of the differences between what you see here, where for each x there's an f of x and a g of x versus this. Okay. All right. So let's look at the first example. So letter A. Let's look at 3A. So let's say in 3A we want to find g composed with f at -2. The idea is the same as before. So you're going to write the definition. You're going to define this. So by definition, this means g of f of -2. And just as before, I have to find my function value right here. So if you have to go to the side, make sure you do that. So I'm going to go ahead and use a separate sheet of paper. So this is going to be 3a. So 3a. So I need to find f of -2. So let's think about what that means. So f of -2 means what's my y value when x is -2? But remember, I have to use my function f. So here's my function f. So when x is -2, I see it right here, right? When x is -2, my y value is 4. So f of -2 is 4. So now that means this. That means this function value right here is 4. So now I have to find g of 4. And so g of 4 means I go to my function g, and when x is 4, what's my y value? Well, let's see. Let's find where x is 4. This is not 4. This is 4. So when x is 4, my y value is 6. So what that means is that in terms of your answer, g composed with f at negative 2 equals 6. So the answer, g composed with f at negative 2 equals 6. All right? Very simple, right? Very simple process. Letter B. So let's say in B, you want to find f composed with g at 3. Okay, it helps if you write the definition. You should. So by definition, this means f of g of 3, right? So remember, I am looking for some work. So don't just give me the answer. I want to see your thought process. I want you to tell me what you're doing. So what you're doing first is to find the answer to this is you're finding g of 3. So write it like this first. That's your thought processes. So g of 3 means, so let's think about this. So in your mind, you're saying this. You're saying g of 3, right? So I need to find my y value. So when x is 3, what's my y value for my function g? So I must go to my function g. So I must go to this function right here. So when x is 3, g of 3, which is this is where x is 3, is 0. So my y value is 0. So I just found my y value. My y value is 0. So now, so this is now 0, right? So now I got to find f of 0. F of 0. So this says I go to my function f, which is this one, and when x is 0, what's my y value? Well, when x is 0, there it is right here, my y value is negative 3. So remember, this is x, this is y. And so therefore your answer, f composed with g at 3, is negative 3. So f composed with g at at 3 is equal to negative 3. All right, C, let's look at C. So C, you want to find f composed with f at negative 2. Well, by definition, this means f of negative 2. F of negative 2. So now I have to find f of negative 2. So let's find f of negative 2. So in your mind, you want to find f of negative 2. So what's the y value when x is negative 2 for my function f? So I go to my function f. Here's negative 2. My y value is 4, right? Y value is 4. So now I want to find f of 4. My y value is 4. So f of 4, okay, so f of 4 right here, right? So when x is 4, this means when x is 4, what's my y value? When x is 4, remember your function f, when x is 4, my y value is negative 1. So this becomes negative 1. And so therefore, f composed with f at negative 2 is equal to negative 1. Very simple, not difficult at all. D, now you want to find, let's say you want to find g composed with g at negative 1. G composed with g at negative 1. So by definition, write out what this means. That means g of negative 1. So now we got to find that innermost function value first. So we got to find g of negative 1. So that's, let's see, 3D. So 3D, you want to find g of negative 1. We forgot to put this one. So f of negative 2 was 4, right? So that's 4. All right, so g of negative 1 says I go to my function g, and what's my y value when x is negative 1? So when x is negative 1, my y value is 4. So that means this right here is 4. So in terms of my problem here, I found this right here. G of negative 1 is 4. So I'm going to find g of 4. So g of 4 means I go to my function g, and what's the y value when x is 4? So here's g. Here's where x is 4. My y value is 6. So the answer is 6. So that means g composed with g at negative 1. So the answer, g composed with g at negative 1 equals 6. That's a 6. All right. And let's do one more. Let's do this one. since I'm running out of room for this problem, let's look at this one. Let's find G composed with F at 0. G composed with F at 0. All right, so by definition, G composed with F at 0 means G of F of 0, right? So it's listed first, listed first, what's listed second, listed second. So you're finding F of 0 first, and whatever that is, you're going to put it inside of the function G. That's what that notation means. So F of 0, so if you look at 3e, you want to find F of 0. So you go to your function f, and whenever x is 0, you want to find your y value. So when x is 0, that's my y value is negative 3. So this right here is negative 3, right? So f of 0 is negative 3. So now I want to find g of negative 3. So that means I go to my function g, and wherever the and I want to find the y value when x is negative 3. So here's my function g. Here is x equal negative 3. My y value is 7. And so the answer, you're going to say g composed with f at 0 equals 7. All right, so that's number 3. So it's very simple using the set of ordered pairs, right? Just like the table. Very simple process. Let's do one more of a set of ordered pairs, number 4. Let's do one more. All right, so number 4, you have your function h. So h consists of these 4 sets of ordered pairs, these 4 points, and g consists of these 4 points as well. And so in 4a, let's say you want to find h composed with g at negative 5. So just as before, always think of what this means. So by definition, this means h of g of negative 5. And so now for 4a, I need to figure out what g of negative 5 is, right? So 4a, g of negative 5 means when x is negative 5, what is my y value for my function g? So here's where x is negative 5, my y value is 2. So g of negative 5 is 2, which means that this function value right here that I was trying to find is 2. So now I got to find h of 2 now. So h of 2 means I go to my function h, which is this one, and when x is 2, here's where x is 2, my y value is negative 7. And so therefore the answer, you're going to say h composed with g at negative 5 equals negative 7. Very simple, right? Very simple process. Let's do a couple more with this number, with problem 4. Let's suppose this time you want to find g composed with h at 3. G composed with h at 3. So by definition, this means g of h of 3, right? G of h of 3. So I got to find out what h of 3 is first. I have to find that inner function value. So for 4b, I need to find h of 3. So let's find h of 3. So h of 3 means when x is 3, what's my y value? But I have to use my function h. So when x is 3, there's where x is 3, my y value is 7. So h of 3 is 7, so that's in your mind, and you now know that the next thing you're going to write down, you now know that it's 7, right? So now you got to find g of 7. Well, g of 7 means I go to my function g, and when x is 7, what's my y value? Well, my y value is negative 4. So this becomes negative 4. That means g composed with h at 3. So g composed with h at 3 equals negative 4. And that's it. That's all you do. Let's look at another one. So C, let's suppose in C, you want to find g composed with h at negative 4, let's say. All right, by definition, and again, at this point, you should have the idea. You should be able to do all of these problems dealing with composition given a set notation or a set of order or a table of values. By definition, again, know the definition. By definition, this means g of h of negative 4. And so let's find that innermost function value first. So h of negative 4, so this is C, h of negative 4 means I go to my function h, and when x is negative 4, I find my y value. My y value is 3. So h of negative 4 is 3. And now I know that this little part right here, that right here that I was trying to find is 3. So this becomes g of 3. And then I go to my function g, and I got to find my y value when x is 3. So when x is 3, which is here, my y value is 2. And so there's your answer. So g composed with h at negative 4 equals 2. That's the answer. Let's do one more with this. Let's do this one. Let's do D. So let's do h composed with itself at 3. H composed with h at 3. All right, so by definition, this means h of 3, right? H of 3. And so for D, we need to find h of 3. Well, by definition, this means what is the y value when x is 3? Well, when x is 3, which is here, my y value is 7. So h of 3, in your mind, so this is your mind right here, h of 3, but this is what you're going to write down on paper. So h of 3 is 7. So now you're going to find h of 7. And so you go to your table, you go to your set of ordered pairs. And for your function h, when x is 7, what's your y value? Well, when x is 7, my y value is 0. So this equals 0. So therefore, your answer, you're going to say h composed with itself at 3 equals 0. And that's it. So that is, let's go back to that first page. So that should help you with the topic on evaluating composite functions given a table of values or a set of ordered pairs.